This is 2.5 part B. So 2.5 B. The one we just did. I said it was 2.4.
Yeah, you did. 2.4 imaginary numbers.
Should be 2.5. Sorry. 2.5A was the previous lesson. My bad. And then this is 2.5B, complex numbers. My video is messed up. It's okay. I'll change it on the title, so that will be fine. All right, complex numbers just means you have a whole number and an imaginary number. So if you look at this, it says 5 plus 2i. 5 is the real number, and 2i is the imaginary part. So when you're combining 5 and 2i, you get what's called a complex number. That's all that it means. It means you can't simplify it anymore. It'd be the same if you said 5 plus 2x. Can we combine 5 plus 2x? No, right? We would call that an algebraic expression. So a complex number is a plus bi, lowercase I. All that it means is a represents any real number, any whole number. The b represents another whole number, and then there's an I. So that's the imaginary number. So a complex number just means you have an imaginary and a real number together.
Now,
that's all that it means.
Now, in this case, since neither of these, since one has a variable, one does that mean we multiply by the divisible one?
No, stop. No, you're going too far. Stop. Why don't you just wait and see what happens? Okay. Number 1 says adding and subtracting. Oh, man. This thing is a little temperamental.
Maybe it's the operator.
Ooh, probably. Adding and subtracting complex numbers. Okay, guys, this is super easy. What if that said negative 11 plus 3i plus 9 plus 2i? What if those i's were x's? Could you do...
You'll combine like terms, right?
Stop talking. Okay, so if it was just like negative 11 plus 3x plus 9 plus 2x, Brooklyn, what did you just say?
You combine like terms.
All you would do is just combine like terms, right? Same concept here. This is not multiplication. You're not going to distribute because there's an addition sign between them. So we're going to rewrite this without parentheses. Negative 11 plus 3i plus 9 plus 2i. And now you can combine like terms. Again, we're not multiplying because they are not smashed together. So negative 11 and negative 11 and 9 make what?
Negative 2.
Negative 2. And then I have 3i and 2i make
5i.
plus 5i. Done.
That is simple.
Now, you can write it like this. Look up here, please. You can write it 5i minus 2, and it's the same thing, right? The 2 is still negative, the 5i is still positive. It doesn't matter to me which way you write it. I will probably write the complex number or the imaginary part of it after it. I'll probably do the whole number first, okay? So let's try number 3. Now this one's subtraction. So what do we have to remember when it's subtraction? You have to change the signs of the second group, right? So 7 minus 2i minus 2 minus 6i, right? We have to distribute that negative sign. So now I'm going to combine 7 and negative 2. Makes 5. Negative 2i and negative 6i makes negative 8i. How do you feel about that one?
Great.
Okay, try 4 on your own. Pause the video and try 4 on your own, please. Okay, so you should have negative 9 because negative 14 and 5 make negative 9. And then 6i plus I because that turns into a positive I when you distribute the negative sign. 7i minus 3i gives you 4i. Okay? Again, if you have 4i minus 9, it's the same thing. Okay, let's try multiplication. So, guys, So on number 5, we're going to now distribute because now we have multiplication. And we have to remember that multiplying I times I, what is I squared turn into? -1. So in that little recall button there, or that recall box that you guys have, write I squared equals -1. So right here, I squared equals -1. We need to remember that. So if I did 2i times 8, what do you think that's going to be, Daniel?
2i
Times 8?
that's -8.
Okay, look up here. 2i times 8 is what? 2 times 8 is 16. And then we have an I there. Okay. 2i times -3i, -6i squared. Now, we can't leave this as is. Can we combine these? Are these like terms?
No.
Why are they not like terms? Good, because 1 is squared. So, but we can deal with this I squared. I squared becomes what? -1. So then I really am multiplying -6 times -1, which means that becomes a +6. Okay, number 6. -I times -2 is going to be what? 2i. +2i. Then -I times 10i gives you -10. Good. I squared. But I squared, okay, turns into -1. 10 times -1 is, well, -10 times -1 would be a +10. So 2i plus 10. Anyone else have this as their answer? Okay. What do you think about number 7? Woo! Say that again.
Foil.
Cedric says the FOIL method, which is the same thing as distributing, right? So we're doing that big, long distributing where you do 7 to both the 4 and the -I. And then you do -I. I'm sorry, and then you do I to the 4 and -I. Okay, so go ahead and do that. 7 goes to 4 and -I.
Okay, yeah. Okay.
And then the I goes to 4 and -I. Don't get in a rush.
Right.
Good, yeah.
Remember how to distribute. I remember back in high school I went to tutoring for it.
Oh, perfect. I don't want you to tip back. I don't want you to fall. Thank you. Oh, wait. Did you forget this sign?
Yeah.
Is it negative on yours?
Is it supposed to be?
Right, because 7 times a -I will give you -7i. Yeah, it
So
does.
whenever you combine them, it's going to become, like, you're going to get your I squared, or I to the third one.
Where would you get I to the... Can you combine I and I... Okay, right. You cannot combine I and I squared, right? So this becomes 28 minus 3i minus I squared. But we know that I squared becomes -1, so I have -1. So that really means
It's positive.
+1. So I have 28 minus 3i plus 1. So that really gives me what?
29 plus 3i.
29
I mean,
plus
minus
3i.
Minus.
Yeah.
Excuse me while I get my sons mixed up for the 50th time.
29 minus 3i. Any questions about that one? You okay with it and just making some silly mistakes? Okay. Try number 8 on your own, all the way out, without talking. Go ahead and pause the video and try number 8.
That's what it was.
So I have negative 10 plus 14i minus 12. Negative 10 and negative 12 make negative 22 plus 14i. Did anyone end up with this answer?
Me.
Not as many as I was hoping. Okay. Any questions on number 8? How we got where we did? We're doing another problem, so just chill. All right, let's look on the next page. The top of the next page says complex conjugates. Sounds like a really big word. Not a big deal. Conjugate. Complex conjugate. All that means is two complex numbers are called complex conjugates if the signs are opposite. So everything looks the same, but the signs are opposite. Do you guys remember when we were solving difference of squares?
Yeah.
And I had x minus 5 and x plus 5? These are called conjugates. Why would I want 1 minus and 1 plus? Does anyone remember why you want 1 minus 1 plus?
To balance it out.
It's so you can redistribute.
Don't tell me.
It's so that, what happens when you do this? X squared minus 5x plus 5x minus 25. What happens here?
They cancel out.
And you just have x squared minus 25. If these signs were not opposite, this would not cancel. Okay? So that's what we're thinking when we're thinking this. If I want to end up with a whole number with no i's in my problem, I need to multiply by the conjugate. Okay? So let's go ahead and multiply number 11. And we're going to hope that we get only a whole number, that all of the i's get out of our problem somehow. So let's try number 11. Just like you did the previous ones, you're still distributing carefully. Who is that? So negative 8i and positive 8i cancel each other out. So we have 64 minus I squared. But we know that I squared turns into negative 1. Negative times a negative 1 is really plus 1. So I have 64 plus 1, which gives me 65. Notice all the i's are gone from the problem. You see that? Okay.
So it's the problem itself.
So when you get, you didn't get that answer?
No, we forgot to add them.
Oh. You just 64 plus 1 you stopped at?
Yeah.
Okay, so when you have a conjugate, that's the purpose of the conjugate, is to cancel out the i's and to get a real number. You guys see that up here? It says the product of two conjugates is always a real number. You need to know that. The product of two conjugates is always a real number. In other words, the purpose of a conjugate is to get a real number. You need to know that.
Yeah, but how are we supposed to go back and check it?
How are you supposed to go back and...
Once we get the whole number, there's no way to go back and check it.
So then you can just recheck your math and make sure you did it the right way.